Here's the guts of an IKS Photovoltaik ST02 photovoltaic module simulator. It's designed to produce up to about 24 watts at up to about 1.2 amperes. Really all it consists of is a linear current regulated power supply, and then it has a whole pile of forward biased power diodes in a series string of 30 in parallel with the output, which effectively simulate, well, not just simulate, they actually perform the equivalent role of the parasitic forward diodes in regular photovoltaic cells, because a photovoltaic module, or technically a photovoltaic cell at the lowest level, is effectively a current source that is in parallel with a forward bias diode. And so what this does is this is the current source, which that operational amplifier, these transistors, now operational amplifier is a base driver for these transistors. That's performing the role of the current source, and those diodes down there are the role of the forward diodes. Very simple device overall, especially considering that this thing was probably hundreds and hundreds, if not $1,000 or more back in the late 2000s. All the date codes in this are a range of about 2006 to 2008. And the design of the circuit board was September 1st, 2005. And that's when it was dated. And of course, it's the year, month, day format because it's a German-made thing. Overall, quite simple. On the underside of this aluminum frame channel, there's a toroidal transformer that goes to this bridge rectifier, film cap there, bulk ripple suppression capacitors for the main DC output supply. Then over here there's this second transformer, 3.6 VA at a pair of 15 volt 120 milliampere rated windings. What that is doing is that is providing a positive and negative power supply, which are regulated by this pair of linear regulators. There's a 78L15 and a 79L15, positive and negative 15 volt respectively regulators, and that's what supplies the pair of operational amplifiers that drive this thing. There's a TL072 right here. This is providing really the current drive signals. These are a bunch of fixed passives and trim pots there, which have the hold in place black goop on the adjustment screws. And then there's this TL084 up here, which is serving as the base drive current supply for these two transistors right here. And of course, this is a TL084, so it's got 4 operational amplifiers inside the package on the die. And the reason for the 2 that are unused with this is you can have up to 4 transistors. And actually, this device could be modified. You'd have to drill the holes and add the extra transistors. And add the extra emitter current monitoring resistors. That's what these, well, current monitoring and current sharing resistors, so that way the current between the 2 transistors is evenly balanced. That's what these 2 330 milliohm ceramic block resistors are doing. And kind of interesting that they didn't use the positions for this on the main board, but it was, I don't know, probably may have had issues because this bodge board, there are no terminals the way everything else is landed on this, because, the way the Germans make it, it's either God tier or borderline Chinesium, and there is no in between. So everything's all really nice and fancy, and then on the underside of this, I just have these 4 bodge wires just hacked on. Then there's this secondary board under there that has the aforementioned buttload of 30, I think those are 6 ampere rated diodes. Certainly they're the right size there, P600As. And then those resistors there are just to simulate other aspects of the parasitic resistances in a photovoltaic module. Well, technically an aggregation of photovoltaic cells, because those parasitic resistances all more or less effectively scale. So yeah, it's a fairly interesting thing, but certainly would not have paid whatever this thing cost new, but for like $15–20 ain't teabag. Also, should you come across one of these for sale, the output current is the only thing that can be controlled. When unloaded, it floats up to in the neighborhood of about 20 to 23 volts. And you can't really adjust that. I mean, these could be modified to turn into linear power supplies, but given that you can get halfway decent linear power supplies for less than what these things typically go for on the used market, these are really for use as solar simulators. And because I've got a couple of them here, this is what the front panel of one looks like. Just a potential meter, current meter. These two terminals are for external measuring of the output potential. These two terminals are for the measuring of the output current, and that's why it has this jumper thingy in here, because you take this out, it opens the output and it isn't going to output anything. Then there's the facility for adding a bypass diode in the event that you've got multiples of this unit in series to simulate a higher than roughly 12 volt nominal array. Output protection fuse in the event that something goes horribly wrong. One of the transistors shorts or something. And because ordinarily it is inherently current limited, but you never know, bad things can happen. And the output terminals down there. Of course, power switch. Current setting, which is fixed, 400 milliamperes, 800 milliamperes, 1.2 amperes, or it's variable. And for adjusting the output current, you've got this quite fancy precision trim pot right here. So yeah, quite well made, just fairly expensive and very academic. Because this is, again, as part of a system that IKS Photovoltaik make for training students in electrical labs, really.